Okay, I thank the organizers for letting me discuss this paper, Manipulation-Proof Machine Learning. Last year, I was here exactly the same time, presenting my paper entitled AI as Structural Estimation. So, no surprise, this year I'm presenting this discussion of manipulation-proof machine learning as structural estimation. So here's what happens. When there is private information, a naive policy will suck because people will strategize against your policy. You want a sophisticated policy that incorporates such strategic manipulation, which is possible if you know the deep parameters like the cost of lying or faking. And experiments can help identify these parameters, but are, of course, costly. So the authors are currently investigating non-experimental ways as well. Okay, so here's the model. It's 3 p.m., so rather than Greek letters, Japanese animation. You are the planner, and you are facing agent of type theta, which you don't know. And the agent tells you x, which could be different from theta, and there's quadratic cost of lying. And then you, as the planner, will give the money, function y of x. Here's your money as a function of x. Agents takes home the money minus this whatever psychological or pecuniary cost of faking. And the planner, or the welfare, incurs this loss function that is also quadratic in what the planner should have given versus what the planner actually gave. There are two parameters. One is the cost parameter, gamma, that governs how x and theta are related. And the other is the beta, which parameterizes the planner's policy function, y of x. So the problem is, you are the structural planner. Your objective is to give money to sort of good people, credit-worthy people. You don't know how good each person is, and you can only observe their behaviors, x. Now, if you just believe what they tell you, that I'm as good as x, well, you pretend x is theta, theta is x, your performance will suck. You could do better if you know something about the cost function, c, for the agent's lying or manipulation. You can model the agent's, model the agent's sort of optimal cheap talk, how the agent would optimally strategize against you, x star. Use something like its first order condition to estimate what their true types must be, and use something like that to optimize your policy and find the right beta star. Note, the cost function c must be policy invariant, because that has to be structural. It shouldn't change across your orders. I think it's a little debatable, but the choice of statistical method for beta is, to me, a little tangential or orthogonal to the fundamental question of private information or unobserved types. Whether you use OLS or lasso, your performance will suck as long as you feed the raw x. You have to pre-process x, given something like the agent's optimizing model. So the main task is to identify and estimate the c. And here's how they do it. Step 1, do survey, or you also talk about something like digital trace, trying to directly observe something like theta, with or without that. Give them an app, give them control policy, which is no policy. Beta is 0, so there's no link between x and y. Spy or record what they actually do when they are left to their own devices. So that's going to be their baseline behavior, x note. Then step 2, give them some random orders or incentives to do something else, like x tilde, and infer their cost c for doing something else. Now that you know the cost parameter in step 3, you can design optimized policy, beta star. Okay, so here's the comment and wish list. As an overview, I think the paper could become, well, in its finished form, of course, after experiments and non-experimental parts, could become very nice empirical development work that combines theory and experiments in a cohesive, what I see as structural model. My issue is a little bit about wording. The word estimating is also used for the decision rule that is optimal. That sounded a little confusing because the real estimation task immediately is about theta, or mainly C, and not beta. And the statistical methods are, in the end, conventional. The main point of the paper is that with private information, you want to invert the agent's optimization model, or how they cheap talk, which requires you estimate C first. So if the authors want to push the statistical method front further, as a reader, I'd like to see maybe some more general properties of how different statistical methods perform under strategic manipulation, which might require a bit more than showing a few numerical examples. Of course, I guess proving something super general about general manipulation might be impossible, so specifying the exact forms for which we can get concrete results would be a great step. Comment number 3, experiments. It would be great if the authors could argue preferably with some evidence, that the cost estimates or the parameters gamma are actually policy invariant, or are expected to be policy invariant across different kind of rules, and that they don't necessarily rely on strong functional form assumptions. And if they can accommodate certain unobserved heterogeneity, that's going to be great. And I'm going to be a little more precise about point C. So currently, all kinds of heterogeneity among agents are either observed or loaded onto cost C, under the assumption that all agents are equally sophisticated or strategic about their behaviors. But it seems likely that some are more savvy than others. Or likewise, some people might be just too busy with their real work, making money, rather than playing with their phone forever. If that's the case, then the lender might want to target type B, who are actually doing work and too busy to strategize, and get rid of type A people who are just strategizing forever. Because what matters to welfare or loss function is the true theta, not necessarily C itself. Of course, separately identifying theta from degree of sophistication or strategizing, let's call it sigma, would be maybe another paper. And of course, C might change across policy, and sigma would certainly change across policies. So that's going to be maybe a next agenda. My final comment. So large experiments are costly, and in some contexts, like at the industry scale, might be infeasible. And which is why there are all sorts of empirical mechanism design, auctions kind of papers that deal with pretty similar problems, like bidder types of private information. Bids are observable actions that are kind of strategically manipulated. And there are all sorts of heterogeneity across bidders, goods, and auctions. So I don't know if this is the direction you are going in the immediate future, but the non-experimental section could benefit from this rich, high-quality literature about how to deal with private information and getting to structural parameters, which sounds a lot like empirical I/O. Well, it is structural microeconomic work, in my view. Thank you very much.